Hello, parents and teachers who may be watching. Welcome to Creating Math Ahas for Parents. I'm Dr. Sandy Atkins, Sandy. And in these videos, I try to share with you some of the things that your children will be doing in school to help them learn mathematics. Now, I took July off. I hope that you had a good July and that as we're getting ready for the new school year to start, I thought we'd look at some of the key materials that your children may be using to help them learn math. So we'll do this over several sessions through August. I try to post on Tuesdays around 2 o'clock here Eastern Standard Time. So keep an eye out for those. And I'd like to welcome new subscribers. Thank you so much for subscribing. It really does help and make a difference. And if you haven't subscribed, please consider doing that. It's free. And also click on the notifications bell to know when these videos are available. And if you find it helpful, I hope you'll give it a thumbs up and share. So again, we're going to look at these materials this week. Next week, we'll look at 5 frames and 10 frames and some of the other models that you might see your children using. And each week, I'll post a different video to look at those models. So here are some of the base 10. We're going to start there. We have Multilinks cubes and Unifix cubes. Now, as we look at these base 10 materials, I think you'll see pretty quickly why they're called base 10, right? We've got ones, we've got tens, we've got hundreds, and there's also a thousands cube. Okay, now think about it's for place value. Now, depending upon the curriculum, some of the curricula out there will name these different things. They might name these longs, and they might name these flats. I tend to just use the value, 100, tens, and ones for the link for place value. But if you hear flats or longs, this is what your child is looking at. And sometimes the reason they do that is that we also use these for decimals later on. And I'll show you that. Now, think about how nice this is. Here are my ones. Here are some tens. Here are the hundreds. And the nice thing here, if I look at the ones, 10, and 100, see, one of the things we want your children to understand is that as you move over in a place, and I could have put them this way, you want to match the places for the number, that a number in the tens place is 10 times greater than a number in the ones place. The number in the hundreds place is 10 times greater than the one next door, than the number in the tens place. It's 100 times greater. Or this is 1/10 the size of this. This is 1/10 the size of this. 1/100th the size. So there's more to place value than just knowing what value is in the place. It's also knowing the relationship of the places. And these models help us do that. You can see that 10 of these will go to make this. 10 of these will make this. 10 of these will make the thousands block. Okay, so it's a very nice physical model for your children to use. Now, you may see I also tend to use paper versions of that model. And the paper versions, I use them very specifically, and I'll show you a little bit why. But see, I have paper versions. I've laminated them. This is just cut out of centimeter grid paper. So it's the same idea, okay? But one of the things that we want your child to understand is that I can cut this up. I could cut this into 70 and 30, 80 and 20, 60 and 40. And you can see this is faded a little bit, but I use a dry erase marker. Here's 70 and 30. Now, one thing for your children is when they look at this, they still see all of those little squares, right? And I could use a dry erase marker on these too. But what's nice is paper lets me flip it over. So when I ask your child to draw what they see, they are less likely to try to draw those squares if I can just flip the paper over. So we have paper versions, we have the commercial versions, right, that have that feeling to them. And I can use these for different things. I'm sure you could see I could use them to help your child add numbers together. I could put them horizontally or vertically and have them look and build the idea that when you add 44 and 23, tens go with tens and ones go with ones. I could have put it this way where they're side by side. Tens still go with tens. I could have demonstrated and put it this way for one of them. See, the nice thing with the model is the orientation of the blocks won't matter. This is still a 10 and these are still ones. So tens go with tens, ones go with ones. If I'm removing values, I remove tens from tens, ones from ones. And then there are some key things we do when I need extra ones of these, right? I don't have enough ones. So let's say I have a model or I have a problem that's something like, I'm going to do 256, and we're going to remove 178. Now, I could pull out 256, build it, remove the 178. And I'm sure you're starting to picture, oh gosh, I don't have enough tens and I don't have enough ones. I'm going to need to do some regrouping. But now I'm just going to draw a picture instead. Here are my hundreds. Here are my tens. Here are my ones. If I want to remove 178, do you see removing the 100 is not hard. Removing the 70, now I don't have 7 tens, but do you remember what I showed you here? I could cut this into 70 and 30 and remove that 70. Just like I cut the 100 into 70 and 30, I could cut a 10 into 8 and 2 and remove the 8. See, these models help us handle problems that can be quite complex when I learn the algorithm, but are pretty straightforward if I know how to draw the picture. And if you look here, I've got 30, 40, 50, 60, 70. And I've got the 6 and 2 more is 8. So 256 remove 178 is 78. So the base 10 models let us model this and help build not just the mechanics of computation, but the understanding. Now, I can use this as your child gets a little older, right? Let's say I have 3 groups of 32. Put them together like this. Here's 32, 32, and 32. See, I've got 3 groups of 32. But how did I build that 32? Sorry that this is off. Well, I built it with 3 groups of 30. And I put that together with 3 groups of 2. If you look at some of the multiplication videos, you see this is an equal grouping model, same amount in each group. But notice I'm showing this 32 as 30 and 2. 3 groups of 30, 3 groups of 2. This is a model for the distributive property. Okay, so I've got 3 groups of 32. I can model it with these. Sometimes you'll see that I'm going to model a problem like this one. This is 12 by 13. And when your children are learning an area model for multiplication, they'll learn that this needs to be solid, a solid rectangle. But if you notice how I just built this, see, I've got this length is 10, and this is 3. This length is 10, and this is 2. So if I'm doing 13 by 12, I can think of it as 10 and 3 by 10 and 2. Excuse me. As you look at this, you see this is the distributive property. Now, some of you might have learned a mnemonic to remember how to do distributive property. FOIL, first, outer, inner, last. That works when you have 2 by 2 terms, binomial by binomial. What essentially we want to make sure we do is we take each of these terms times this. So if this became a trinomial, FOIL doesn't work anymore, but we still need all of those dimensions. But if you think about it, what do I have? I have a 10 by 10. Here's this right here. Right? I've got 3 10s. I've got 2 10s. And then I've got these 3 2s. See, it's a very geometric way, for approaching the distributive property. And base 10 blocks let us do this. Now, base 10 blocks aren't restricted to just this. And there are ways, again, if you look at the multiplication videos, especially the grade 4 one that shows, you'll see me using the paper versions because we want your children to be able to also draw these pictures, and the paper lets me draw them a little easier. So I'll try to leave a link below to that so you can see those. But now see, I can also use these base 10 materials. I've made a little centimeter measuring tool because when your children start to measure in school, we need them to know the size of the unit. And sometimes those commercial rulers are just too busy for your children. So I just tape some of the ones together. These are centimeter cubes. We can measure with those. I keep showing this. I haven't been leaving it out. Let me make this a little wider for you to see. Okay. Now, this is great. I've shown you how we use some base 10 materials early on for place value. We can use them for computation. I've shown you an addition example, subtraction example, multiplication. But the other nice thing is, as your children get into measurement a bit more, they'll see this cube. This is a cubic liter. Okay, unfortunately, mine has a crack in it, but I think you get the gist. If it didn't, I could pour a liter of water in there and it would fit right inside cubic liter. The nice thing is this base 10,000 is the same size as this cubic liter, which when we're trying to help your children, especially as they get into chemistry and some other things, but see, if this is a liter, this is 1/10 the size. It's a deciliter. This is 1/100th the size, a centiliter. This is 1/1000th the size, a milliliter. And I remember taking chemistry, I would be somewhat confused of how a milliliter is a cubic centimeter. But when we look at this model, it's very clear the relationship of this 1/1000th of this. And that links back to our cubic liter. So these models are great for place value, right? They're very good for place value. They're very good for computation and acting them out, but they also can be used for measurement later on, and not just linear measurement, but that capacity, the volume measurement. So we have that. We have the paper versions. Now, I said Unifix Cubes were another tool that we have. Move some of this. And we have Multilinks Cubes. And you may find that your children are using these different models here. The one thing with the Unifix cubes is they connect in one way. That's why they're Unifix. I can only connect them in long rods. Whereas the Multilinks cubes, I can actually make structures with them. They'll connect in multiple ways. So we can make these structures. Now, this base 10 block is a great model, but for your little ones, kindergarten, grade 1, especially into grade 1, we need them to understand that this could be broken up into 10 of these. And what we do is we start here before we get to these, hopefully, and build that foundation. I want them to understand that I could break this up and have 10 cubes and put them, right? And it's going to be the same as this rod of 10. But the other thing is, you remember how I drew across this to show how to break it up? You may find that your first graders, an important idea is ways to make 10. And what we want them to do is understand, I don't have to always split it up into 10 individuals. I could break it. So 7 and 3 is the same as 10. 4 and 6 is the same as 10. And we might have them draw pictures again. So remember in that problem we did, I cut a 10 into 8 and 2. But you may find that your little first graders are drawing something that looks a bit more like this. Sorry for my drawings. Right? We'll pretend that I'm a better artist. Right? So when I cut it into 8 and 2, we might start here, but we want to transition them up into that kind of drawing to show how I could actually cut something apart. So you might see them doing things with Unifix cubes before they get to these base 10. And that's very purposeful because we want to really have this firm foundation about either breaking it into small pieces or actually cutting it and getting this idea here without always having to go to 10 ones. Okay? So, Unifix cubes. Now, the other thing you may see that's great with Unifix cubes that will not happen with at least my fingers with multilinks is these can be placed on the child's fingers. Helps them get a sense of 4, not just holding up 4 or 3. And notice how I don't have just one way of making 3 with my hands. And you will find, especially with your pre-kindergarten children, they may have a hard time putting down the fingers that don't have cubes on them. It's one thing to try when you are looking at it. It's another thing to try when you close their eyes. And we'll do an activity with your children sometimes where one child puts their hands up, they close their eyes, and the other child puts some cubes on their fingers. And with their eyes closed, let's see if I can show you here. With their eyes closed, they try to put the fingers down. Now, did you notice I snuck a peek, right? It's not that easy. And if you don't have Unifix cubes, not a problem. You can always use caps off of markers. These caps off of the markers also work very well. It gives them a sense of finger placement, what's on their fingers, the touch. It helps build those neural connections, but it also just gives them a sense of quantity and ways to make those numbers. So I can do similar to this with these Multilinks cubes, right? But one way that you're going to see Multilinks cubes used with your children, especially when they get up into 5th grade, is you might see a structure that's been built. Let me move some of this out of the way here. Now, one technique that you may find your children are experiencing in their classrooms is a quick image technique. And in that technique, we flash an image at them quickly. I tend to do it very quickly because I'm going to show it to them more than once. And we find that sometimes your children get very scared to take risk in math. And that's a very important quality, is risk taking. And so this is kind of a fun way where they're a little bit more willing to take risk. And here I'm going to flash this image at you pretty quickly. I'll show you in 3, 2, 1. I tend to do these on the computer, so it might be even faster. And I would have told them, your goal is to determine how many cubes I used. Now, it was fast, right? But I'd have your children turn and talk, give a prediction. I might ask, what are our predictions? Write them down, and then I'll show it again in 3, 2, 1. Now, in doing that, I might now ask, well, which of these can it not be? What made you change your mind? Did anybody change their mind? Right? And we'll do that several times and get them to defend why they think and what they're noticing. And then we leave the image up. Now, here's the image I was showing. You can see this is a different style of Multilinks cube. Same idea, though. We made this image, and they may have noticed I've got 2 columns of 3 there, 6. I've got another 6 with this 4 and 2. Now, the nice thing with this quick image too, and here's the model, right? I think this one matches it. Okay. My follow-up question is, could there be more? Could there be fewer? Right? Because the way that this is, right, I could have had hidden back behind one of these. Right? And you wouldn't have necessarily seen it. And so the question, the follow-up question, this is volume. This is volume of structure that's not just a very neat length, width, height, right? So I can ask, what would be the maximum number of cubes it could be? What would be the minimum? Because this one back here, since it is a multi-link, sorry, these two may not be there, right? I could have possibly connected. See if I can get this connected again the way I want it. Hope you get the idea. Do you see now? So I've got this structure. Looks like that. But notice what I have in the back now. So when we start investigating volume, for most of you, that's in grade 5, and they start doing volume and they need to use these weird structures, these multilinks cubes might come in. But it's nice when we can do it in a way that helps your child start to think about maximum volume. It could be minimum volume. What else could be going on in that picture? And defending their answers and justifying their reasoning. So hopefully that gives you a little bit of an idea of how you might see your child and why you might see your child using Multilinks cubes or Unifix cubes, base 10 cubes in different ways, right, for place value, and why you might see paper versions of these, and why we might draw on some of them, right? So Multilinks, Unifix, base 10, paper base 10 out of centimeter grid paper, all some models, key models that your children may be using this year in math. Again, next video, next week, I'll show you some other key models, and we'll continue that throughout August, showing you some different materials your children may be using in math this year. I hope you found this useful. Again, if so, please give it a thumbs up. Please share with others. Please consider subscribing. Big difference to the channel, so I hope you will do that. And again, Hope it was helpful. Thanks so much for watching.